It should be. These are pretty easy, dude.
Yeah, I guess.
I got an answer. You got it. What?
King Henry died drinking chocolate milk.
Hey Siri, what's 34 plus 230?
Really?
She has money.
You're on the late bus or anything?
No, Miss Paul, don't want to be here.
Don't any of us want to be here. We're like rats on a sinking ship, trapped.
Wait, does the one go with the bigger number?
You're really still on number one.
Yes. Answer the questions. But I'm still confused. 16. What goes on the bottom? Oh, no. See? I thought that was mine.
Milliliters, liters, who's bigger, liter or milliliter?
Liters.
Put a one there. King Henry died by drinking chocolate milk, which Allie's been singing since she saw the problem. So, what's on the baseline?
Liters.
Liters, the base units, liters, meters.
Grams.
Get back out here, dumb thing.
This goes left for you?
I'll do the work.
All right, so liters, meters, grams, etc. is on the baseline, right? So from there to deci to centi to milli is how many spaces? So it's 1,000 because there's 3 zeros and 1. Now, I would strongly recommend you memorize that there's 1,000 milliliters in a liter because you're going to use that so much in this particular unit that it's not worth having to draw King Henry or count that all the time over the course of the next week and a half, okay? So if you don't know that there's 1,000 milliliters in a liter, I would memorize that one, okay? So when you divide, you get 0.16 liters. Any questions about that? Yes, no? We're good? Fabulous. All right, number 2. What do you know about centimeters cubed milliliters?
They're the same thing.
They're the same thing. So 5.34 milliliters. All right, we good on 1 and 2? Okay.
What? Say.
Are you close today?
Oh.
So happy.
Right, don't do that again.
All right. Number 3. How do we do grams to moles?
Gram, the
Avocado.
mass. No, you don't. You count.
If you guys don't stop calling that man avocado.
It's only right.
Right.
Yes.
What goes beside moles?
His host has to say it. Yeah.
What goes beside moles? That's 1. All right. What goes beside grams?
16.
Try again.
32.
Because oxygen's formula is what?
Are you kidding me?
It's one of the 7 diatomics. You have to remember that. Put a 2 beside it. And its mass is 32. Okay? So, what do you get when you divide that?
1.79.
1.79, which has correct significant digits. So, questions about that one? All right, to change Kelvin to Celsius, what's the formula?
Look at your reference.
Okay, so Allie looked at her reference table and found K equals C plus 273. Franco asked Siri, because I always pronounce it wrong. All right, 34 plus 273. And what did Siri tell you it was?
There you go.
I didn't actually ask you.
It was 373.15.
It was who? It was who?
No, for the Kelvin.
Kelvin. What are we?
Isn't it
All you have to do
When I asked
273 plus
Google, it said
34.
there was a 0.15.
Yeah, there is a 0.15. But your formula sheet leaves it off, so I don't teach it with a 0.15 anymore.
307.
It
If I did the math right.
It probably didn't
Okay, questions? Questions about 1 through 4?
Surrey gave you the 0.5, Siri did.
The correct formula is K equals C plus 273, and it has a decimal of 1.5 on it. But the state has taken the 0.15 off, so I don't teach it anymore. Okay, but it does have a decimal number. All right, questions about any of those 4? Nope, fabulous. You're expected to be able to convert those at any time.
What's today?
Tuesday,
The what?
5th.
Thank you.
Now, today is open 7, so we should be collecting on Friday. Remember what I told you. If you're missing any, if I don't get them on Monday, they will be marked what?
0.
No, I said I mark them late. And by late, I will take off 10 to 30 points.
Oh my God.
I'm done playing with these. I get them 4 and 5 days late.
Did you say
Okay.
30?
Yes,
Oh,
I did.
That is not what I thought.
Okay, so second periods, I tend to get all of them the same day. Maybe 1 or 2 scraggling the next day. First period, I get 4 and 5 days late. I'm done with that. Okay, y'all are tardy all the time and don't turn in your openings. Get them to be by Monday. So if you know you're missing openings already, take a snapshot of the ones you're missing out of the book and get them caught up. Okay, before we get to Monday and you realize you're missing 2 and wait 4 days to turn them in. Now,
I got 6.
then you're missing 1. If you've got 6, you should have 7. So figure out which one you're missing before Monday.
Or should you yell at you?
Now, the test that you have in front of you, everybody took besides Franco. So Franco's going to need to make it up. Now, you have, I told you that I usually allow test corrections on this one. I will stick by that. However, there are stipulations that go with it. I'm only doing 4 days of test corrections. I'm not extending this for a millennium of test corrections. I'm also not doing it during lunch. Okay? I'm not going to have people in and out, disrupting my planning period for days on end either. All right? Huh?
The morning or the next test?
This one. The next one's all for response.
Okay.
All right, so I have, let me check my calendar, but I'm pretty sure I have it on the top of my head.
Wait, we have to come after school to do it?
Yep. All right, I've got today, I've got tomorrow, I've got Thursday, and next week I have Tuesday. Okay? So, barring this, what's your face there? Wicker giving us the bubonic plague, and I'm out. All right, those are the 4 days we're doing test corrections. I didn't think the test scores were as horrible as some of y'all probably think they are. So, I think 4 days is enough time. Braylon, which day would you like to make it up? Fabulous, I'll be here. So just showing up and we'll make it up. Yes, my dear. Okay. There you go. Huh? All right, so if you make it up tomorrow, that will give you Thursday and Tuesday for your test corrections if you would like to do it. Okay? But that's up to you. Test corrections are not required. Any questions about the test corrections? Anything you just got to know today because you looked at it and you're like, dang, what was that? Anything?
The answer? Is that what you're asking?
Yeah, or something you just want to know about.
What is, what?
What is what?
They give me the answer.
I know, but I mean, you looked at it and you're like, I just don't understand and you want to ask.
Yes, I will.
No.
Wait,
Oh, I have a copy.
does the last, wait, this one counts off 1 point, right?
Yeah, everything was the same as a multiple choice. Nothing was different.
Okay, what other one did I miss? Because I missed 30. Can we go over number 30? Oh, wait, yeah, 30 and 40.
Let me find number 30.
30, you got 30 wrong? No.
You got
What would
30
that
wrong?
grade be if you got 30? Yeah.
Really?
Wait, let's see.
You looked up the oxidation number for aluminum on
I
the
did.
periodic table, and then you look up nitrogen on
What
the
is the
periodic
answer?
The free.
They cancel out.
It's okay, Ellie, I thought I was stupid too, I was using the Ellie shoe.
Wait a minute, cause I know.
So that's plus 3 and that's minus 3 based on where they're on the periodic table. The 2 3s cancel out.
Okay, we're about 45. The crystal lattice.
I think this is, minus one on
The simplest repeating units, the unit cell.
Cause I was.
Those are the 2 questions you got wrong.
The multiple choice.
And I got these mixed up.
The short answers is the only
Those are
one
not-
I like.
I would not have thought that.
But isn't this
That's
not hydrogen? Yeah, what's this
On
donut?
the paper.
Yeah, I know, but like, it doesn't, it didn't have
Oh,
a pair.
it's a zero.
Yes, it does.
Why?
Not that
You
one.
got zero wrong on
This
that
one.
one.
Oh.
Water. Where'd you draw water at?
I was like, how?
Why you got 4 hydrogens on it? It only has 2.
I don't know.
Anybody else?
You make stupid mistakes.
Yes, she did. She should have had 100.
I'm sorry. I get one with test corrections.
What is MC?
You get 98. MC multiple choice.
A 90? There's no point you can do it.
Truthfully, there's not. Not for you, but if you want to, you can. Anybody else?
Now.
Anything you're dying to know?
So what is the extra, what? The correction.
Then you don't get half back. You don't get a full grade.
So what does that mean? Like,
So you got a 90, you get a 95. Get the most. Yes, sir. Oh, I thought you were hearing. Anybody else? They're optional. They are not required. All right, give me your test papers, please. We got things to do today.
So wait, when do we do our test papers or did you have our papers?
After school, those days.
Oh.
You cannot take them home.
Well, I think you missed one.
Happens a lot with Michaela.
I do nothing.
Yeah, I know.
Yes, that's me.
That's why she misses the
I'm
conversation.
a great
She does nothing.
student.
It's not, she did have no luck.
Well, oh, wait a minute, no, I'm not good at what it said.
Oh, Miss Wall.
What?
We send no permission slip?
For what now? I thought I already signed one. Oh, no, I was going to the bathroom yesterday.
Yeah, and you're like, I'm going to get
You had all day to ask me to do that, and then you want to wait until I need to go to the ladies' room.
You got every other.
Yeah, except for third period, but I'm.
And I didn't have my mom's side of it.
You do realize it's tomorrow.
Yeah, I do. Good day. Yeah, I know, we'll figure something out. Oh, that's me. That's why me and my mom have the same signature.
It's amazing the way that works.
Why is there even the notice?
Now, tomorrow, well, I'm thinking about this since Allie asked me to sign her permission slip. A few of you will be here. I will teach, I will record. The first quiz is, tomorrow we'll do 4 gas laws. We'll practice on Thursday. First quiz is Friday. Those of you who are out tomorrow are not excused from the quiz on Friday, okay? You are expected to either watch the video or catch up on what you're missing and be ready to take the quiz on Friday, okay? We will cover 4 gas laws tomorrow. They are not hard. Those of you who are very math-minded, and I'm going to pick on Precious, because she is. She will probably be able to sit in class on Thursday and get it without watching a moment of the video, okay? Some of the rest of you can't do that. You are going to need to watch some of the video, if not most of the video, to catch up on what you missed in class, okay? If you can't do that, I don't know what to tell you, but you can't miss an hour and a half of class, go on a field trip, come back, and expect me to reteach what you missed while you're gone. It's not happening, okay? You are expected to know what you missed while you're out. That is the expectation when I put my signature on that sheet. It wasn't go have a good time and not have any work to do when you got back. Do you understand that? Okay? Yeah, I'm sure. So, kinetic molecular theory. We're going to talk about gas laws. Those of you who like giant titles, sorry, I wasn't expecting you to walk right behind me. All right, giant titles. We're doing the gas laws for the next week and a half. All right, so today we're going to do some notes. We might get started on the math calculations, but this entire unit is on the gas laws and math calculations. So the next test will be 10 multiple choice, which is 20 points. The rest of it is all free response math problems, and that's 80 points to the test. Okay? So, Franco! Yeah. Get in here.
I forgot about that. Where did you go? Why? What?
Because we were going over the test we left. So, kinetic molecular theory is the idea that the particles in a sample of matter are always in motion. Okay? All particles are in motion. It doesn't matter whether we're talking about gases, whether we're talking about solids or liquids. And we'll re-emphasize this after we talk about the gas laws, because it also goes into the next topic also. But all particles in a sample of matter are in motion. Glad I remembered you, or you'd still be sitting back there while I'm teaching. Now, we talked about this in the last unit that we took a test on. So this is actually reviewed. So when we talk about the types of motion that gases can have, okay? Gases can rotate, which is spin in circles. They can vibrate, and they can translate. So in their containers, they can move all around the container. Okay, that's what translate means. Gases have the ability to translate, rotate, and vibrate. Now, can liquids do all three? No.
Yeah.
Can liquids go from one end of the container to the other?
Yeah.
Yes, because they're not locked into position. So can solids do all three?
No.
No. Which one can solids do?
Vibrate.
That's right. Okay? So out to the side, you can write it down or not. We'll talk about it down the road. But solids vibrate only. Okay? But liquids and gases can vibrate, translate, and rotate. Okay? But solids can only vibrate. Is everybody caught up with me, or am I going too fast?
Too fast. Liquids can do all of them.
Liquids can do all of them.
Solids can only do one of them.
Solids can only do one of them.
And gas can do
All of them. Yes. And it's got to do with a property we're going to talk about shortly, which is fluidity. Does anybody know what fluidity means? All right, they're a fluid, but do you know what being a fluid means? Anybody?
Molecules are certain.
Molecules are what, Franco?
Have certain space between them.
Yeah, they have space between them so they can move around.
Right.
Okay? All right. So, when does motion stop? And I've already got the answer there. All right, motion stops at absolute zero. Does anybody know what absolute zero means? Elijah.
There's no vibration molecules there where it's like the coldest temperature.
Yes, can you tell me what that is? It's got an actual top
Zero on Kelvin scale.
zero on the Kelvin scale. All right, absolute zero is 0 on the Kelvin scale, okay? And I put in the temperatures for Celsius and Fahrenheit just to give you something to compare 0 Kelvin to. But absolute zero is defined as 0 Kelvin, okay? That's the definition, 0 Kelvin. Now, if you listen to what Elijah said, at 0 Kelvin, you have no motion. No vibrations, nothing. All right? So I like to use the example of when people die, because most people can't relate to this. When people are dead and they're laying out in the casket, are their particles still moving?
No.
It's the answer I get 9 times out of 10.
Yes, they're parts.
Their molecules inside their body, even though they're dead, are very slow. But are they moving?
Yes.
Yes, because
That's
they're not at
weird.
absolute zero. Now, your hair's not growing, your nails aren't growing, you're not able to move, you're not breathing, you're not doing any of those things. But is your body able to decompose and decay if the molecules inside of your body are not moving?
No.
No. So on a molecular level, your molecules are still moving to some degree because that's what decays and decomposes your body over time. Okay? If the molecules were not moving at all, would your body be able to decompose over time? We'd open up the casket and Allie would look just like she looked the day she died.
Hey.
It might be good, it might be bad. Depends on when you died or how you died.
I like that.
Okay. I mean, if you were in a horrible car accident, you might not look very good. All right. So we're all good with that, right? Now, the reason I put that there is because on the multiple choice section of the test, when I ask questions like, which of the following states of matter have motion? What do you think people pick?
All 3.
That would be fabulous.
Liquid.
Yes.
They pick liquids and they pick gases. Who do they invariably leave out on the test?
Solid.
Without fail. Okay? So just remember that. You don't have to write it down. But just remember that solids have motion. So don't forget that when you're looking at the multiple choice questions on the test. Because it's one that's easy for me to trick people up with in the multiple choice questions. Okay? Huh?
Like solid, liquid, and gas. Like what is their like states?
The states of matter. Okay? It's just an easy one for me to get people on. Do not write this line. These are things I created when I was out for a sub 1 year. That's why they're typed. That's where all my type notes come from, are subs. All right. So what is an ideal gas? All right. An ideal gas is a gas that obeys all 5 assumptions of kinetic molecular theory. All right. It's a gas that obeys all 5 assumptions of kinetic molecular theory. Now, we're going to study ideal gases because it's the easiest type of gas to calculate in a first-year chemistry class, even though ideal gas doesn't technically exist. But it's close enough to what a gas would be that we can calculate with it. All right. Tell me when y'all have it.
Wait, what are the 5 assumptions?
Thank you. What?
The 5 assumptions.
Getting ready to do those. Getting ready to do those. All right, everybody there? All right, so the first assumption. We're going to calculate with gases that have a large number of tiny particles. So, for example, if I say we're going to calculate with 1 mole, how many particles are we talking about? If I say we're going to calculate with 1 mole, how many particles am I talking about? I was worried there for a minute nobody was going to get it. We're talking about that number of particles. That's a huge number, isn't it? If I did half a mole, that would still be a huge number of particles. So even though an ideal gas does not exist, can we create a gas that has a large number of particles? And a word problem. Can I stick to that? Yo, Allie, you with me?
Yeah.
Yeah. Can I create a word problem that has a large number of particles?
Yes.
Yeah, I can give you something that has 1 mole. I can give you something that has half a mole. That's still times 10 to the 23rd. That's a huge number of particles. Does that make sense? Okay.
So it said all gases have those lots of particles.
We're going to only work problems that have a large number of particles. Now, real chemists can work problems that have small numbers of particles. We're just not doing it. Okay? All right, all gases are in constant motion, moving in straight lines. Straight. All right, now, it's a little bit like being on the main hall. Most people, I would hope, are polite and say, excuse me, and go around. They don't. They just bump into you. So, these are gases. They just bump into people. They don't go around. Now, number 3 is a new vocabulary word for us. Okay? All collisions are elastic. Okay? It's a new vocabulary word. Elastic. That means there's no loss of kinetic energy. All the kinetic energy is transferred from one to the other. Okay? So, if this gas molecule hits this gas molecule, all kinetic energy is, let me see if I can make that a little better, is transferred. Now, if you've ever played pool before, all right, if one of the balls hits another pool ball, if you've ever seen one stop and the other one keep going, that's the best example of that I can give you. Doesn't happen very often, but if one stops and the other keeps going, that is the closest you will see to an elastic collision. Now, does this actually happen?
No.
No. You lose kinetic energy to friction and other things. So we're going to assume that there's no loss to those things.
So why is this important if it's not real? Like,
Because this is the easiest way for us to calculate in first year class. And we'll come very close to the way it works in real life. It's pretty close. All right, so number 4, we're going to work with gases that have no attractive or repulsive forces between the molecules. So the only way we can do that is to work with non-polar molecules. Okay, because they had the weakest forces. All right, we don't have molecules that don't attract, but if you remember, non-polar had the weakest forces. So that's why we'll use non-polar molecules, because they have the weakest forces.
No biscuit milk cup today?
No, I try not to have soda every single morning. I've tried to cut back some. So I just had a biscuit. All right, and the last one, the average kinetic energy. And what do we know kinetic energy is?
Energy and motion.
All right, so kinetic energy is motion. Okay, kinetic energy is motion, depends on temperature. So how is motion dependent on temperature? Can anybody tell me what the relationship is between temperature and motion?
Hot, lots of movement.
Okay. So higher temperature equals more motion. Or kinetic energy. Okay, so the more the temperature, the higher the temperature gets, the greater the kinetic energy or motion gets. So if any of you ever have a car or have a car now, when should you check your tire pressure? While it's sitting there and it's cold, or after you've driven it?
After
When it's
you've
what?
driven it.
Holding your seat.
When it's sitting still and it's cold. Because after you've driven it, what happens to the air pressure? The tire gets what? What happens after you drive the car? The tire does what?
Gets flat.
It gets hot.
I'm worried about y'all if y'all think your tires get flat after you drive it. Okay. What happens to the tire after you drive it? It gets hot. So what happens to the air pressure of the tire? The air inside gets what?
Bigger.
It expands because the particles do what?
Move a lot.
They warm up from the heat of the tire. The heat of the tire warms the particles, which causes them to move faster, and that's why they expand inside the tire, and your tire pressure goes up.
Or your car can lie to you when it's cold in the morning and say that you have low tire pressure.
That's where I was going with that. Okay, so does anybody have, I'm going to guess Allie has a sensor in her tire that says tire pressure, and it might say that you have low tire pressure in the morning on cold mornings. And so after she drives it for a little bit, this low tire pressure warning goes off. Okay, because what happens when you drive your car tires? They warm up, and the tire pressure inside, the heat of the tire warms the air in the tire, and then suddenly the low tire pressure light goes off. Okay? Any questions? Now, older cars will not have that technology, but newer cars do. Okay? All right. What conditions will give us an ideal gas? So since we're going to calculate the ideal gases, we have to do 3 things in our word problems that will give us this. Okay? The first one I already gave you. What did I say back here we needed to have in order to have an ideal gas?
All those things. Non-polar molecules.
Okay, we're going to use non-polar molecules. All right, now, we don't want our molecules to be close together. We want them far apart so they can't attract, right? So what do we do to keep these molecules far apart so they can't attract? Do we want the temperature to be high or low?
High. Wait, you
Okay.
say far apart?
We want the molecules to stay far apart so they can't attract. We want high temperature. Okay, so our temperatures will stay high. All right, we will not use low temperature word problems. They'll stay high. All right. All right, and the last one is low pressure. All right, because we want the particles, again, to stay far apart. We don't want high pressure on them, causing them to get close together. All right, so we have these. So the molecules stay far apart and cannot attract. I'm going to send y'all over there with Miss Wicker if y'all going to keep sneezing. Yeah, well, today and yesterday she's typhoid married.
What? She has typhoid?
No.
Oh.
She's got a really bad cold and she keeps sneezing everywhere. If you know Mo, she's over there wearing a face mask trying to make sure she doesn't get sick.
Boy. I should never listen to you.
All right, so a real gas is a gas that just doesn't obey those assumptions, okay? You can have polar molecules. You can have low temperature or high pressure, okay? And they do exist in nature. So an ideal gas does not really exist, but we're going to pretend that it does exist. Okay? We're going to pretend that an ideal gas does exist. But in all reality, does an ideal gas exist?
Never.
No. So for us, and the word problems we're going to work tomorrow, for those of you who are not going to be here, when you try doing the math, because I'm going to give you the sheet so you've got your homework, all right? And yes, if you come back on Thursday and I check homework, yes, I expect you to have the homework, all right? You have problems that will have high temperature, so none of them are going to have a low temperature. They're all going to have a low pressure, and they'll have non-polar molecules. All right, everybody caught up?
No.
Who said no? Okay. All right, now we need to do properties of the gas. And this is the most notes you'll take the whole unit on the gas laws. All right, we there? All right, 5 properties of gases. Number 1, gases have the ability to expand. They have the ability to fill their container. All right, so if you put a gas in a container, will it just sit at the bottom?
Never.
No, it expands to fill whatever container it's in. So when we talk about liquids and solids after this unit, do liquids have the ability to expand and fill their containers?
Yeah.
No. If it did, it could regenerate and refill my Pepsi bottle, which would be fabulous. It would be bad for me, but it would be fabulous. Never happens that way, though. All right. Number 2, gases are compressible. Okay? If you think about the old picture of a gas that I'm sure somebody drew in middle school. All right? They drew something, probably looked like that. It had gas molecules, probably look like that. Okay? What is in between all of those little pictures of gas molecules?
Air. Wait, no. Space.
Space, just empty space, okay? Because the little circles could be the air, could be the nitrogen and oxygen molecules, right? So what would happen if I tried to push those molecules together? Could I compress them?
No. Yes.
Yes.
Good.
Because what's in between it?
Nothing.
Nothing, just space. So I could push them together. I could compress them. Okay? I'm able to do that because there's just empty space in between all those molecules. Okay? So, I mean, if you want, you can write that this is just empty space. Okay? What's wrong, Franco? Anybody have hair ties? What are you gonna do? Put it up on top of your head? What, like pebbles?
Because you can't wear that headband.
Don't brought me back to freshman year.
Sure, you can't wear the headband, and yet if your book photo has it with the headband.
Oh my gosh, we're almost out of here.
Thank you.
Yeah, we're getting close, guys. You realize we have like 24 days-ish or so when we have exams?
And then we have a whole other semester. Right. And this class isn't even the class I'm excited about leaving. Right.
I'm
really excited about
chemistry.
Oh, I don't get to
excited
leave.
about leaving chemistry.
I have bib classes all year that I'm excited about leaving.
All right. So why would density be low for gases?
Because they're in the air, flying around.
Because they have a lot of space.
If they were days, they would fall.
No. What did you say, Elijah?
Because there's a lot of space in between each molecule.
Okay. So thinking about the formula, could you explain it to me that way?
Where is the map?
Multi, maximum volume.
Okay.
There's a
So
lot
what
of
can you?
space with smaller amounts.
Okay.
So no math.
So if you think about the formula, the mass is very small and the volume is large. So in math class, what happens when you take a small number and divide it by a large number?
Get a small number.
You get a small number, okay? All right, so anytime you have a small mass and you divide by a large volume, you're going to get a small number, right? Y'all in math class years ago. So I was looking at me like, yeah, right. Just get me out of here. You won't be here tomorrow? You're watching a play, right?
She's just looking at the board in this wall, and you just try to take all that from her.
Okay.
She could be excited about being here.
She doesn't look excited. I'm just thankful she's been on time lately. You were here on time. Xavier was here on time. Everybody was here on time except Trevor. I don't know what's happened lately. Trevor's fallen off the wagon.
Trev,
I get everybody else on time, and then I can't get Trevor here on time.
He's trying his best.
All right, so fluidity is the ability to flow. Just these molecules can move around. So we can get up and leave class and go to second period because we can walk through the air. If we couldn't walk through the air, we would have a problem. It would not be a fluid. For example, if I try to walk through this lab counter, I can't walk through the lab counter because the solid is not a what?
Liquid. Wait, what'd you say?
I can't walk through this lab counter
Why
because
is
it's not a what?
When,
It's not a fluid, the molecule's don't move.
yeah.
Why is it when like there's a volcano and then it starts like the ashes, you said moving through air.
Yeah.
And like all the ashes come down, why can't people move?
What?
They
I think
get
she's
like
talking
buried
about,
in ashes and
like-
they can't move and they're stuck.
Like, I think you're talking about
They
like the
usually
Pompeii
die
things, how they like.
I'm assuming they're either dying from the heat, their lungs burn, or it solidifies and they can't move. I'm not sure which one you're referring to in which stage.
Not the actual lava, the ashes.
It's still hot though.
The ashes are
The
hot.
ashes
Yeah,
come
they
from,
are.
Yeah, the ashes are hot.
Ashes are hot.
the ashes come from like the natural burning things. So most times the people are the ashes.
Have you
It's like
ever
you catch
dealt with a
hot
fireplace and
marshmallows.
ashes? They're hot.
Okay.
Being a lot of things,
I
water.
mean,
Just saying.
cigarette. I'm just kidding.
Yes, yes, water.
Whoa,
All right, the last one.
That is nasty.
All right, the last one is diffusion. Gases have the ability to diffuse. Notice I said it's the spontaneous mixing of two or more materials. Spontaneous means, can you control the mixing?
Never.
No. Which is why your friends, family, classmates, teachers get upset when students, A, pass gas. All right, because it's the spontaneous mixing. It doesn't stay in your small sphere over here around you. It spreads. Everyone gets to enjoy the scent. All right. Some of us who are who have asthma or who just don't like strong scents don't enjoy students who spray their colognes and perfumes on before they leave class. Those scents don't stay just in their small area. It spreads. Okay. So diffusion is the spontaneous mixing of two or more materials. Okay? Questions about that? No? Fabulous. We got to talk about, I already said yes.
I did not hear you say that.
She really did.
Hey. My bad.
It's okay.
Don't let it happen.
What happened to your hair, bud?
Oh, I didn't get it right, so. that's
Well,
okay.
try harder.
All right. So we're going to calculate.
Is this the same thing?
Yep, moving on to pressure. We're going to talk about calculating with pressure, and then we're off to the gas laws.
This is under the molecular.
Nope. We're on to number 4.
Property. Oh, is this the one?
Yep, we're on number 4.
Pressure conversion?
Yep, we're on to pressure conversions.
That was wrong.
Hey, Michaela. That's an interesting look, Franco.
Yeah.
It's
Although we can see your face that way.
right. Look at you. I like the idea of calling maths. It made sense.
In your world.
Yeah.
What is like, you know, people say like you're your own world.
Wait, the title of this is pressure conversion?
Say what now?
The title of this is pressure conversion?
Yep. All right, so
The previous one was.
we're going to talk about pressure conversions. And then when I teach the gas laws, we're going to leave out mass moles tomorrow and largely Thursday, okay? Because I'm going to divide up the way I teach the gas laws into 2 sections, without mass and with mass, to try to make it a little easier for me, okay? So we know how to convert volumes, right? We practiced that a little bit ago. We know how to convert temperatures. We practiced that. We know how to change mass and moles. We've done 1 through 3. We practiced it in the opening, correct?
Right.
Theoretically, we all know how to do that. So if we're struggling with 1, 2, 3, come see me and get some help. So pressure is what we need to learn how to do. So what is pressure? We haven't really talked about it this semester, so we need to do that. Pressure is a force per unit of surface area. Okay? Force per unit of surface area. Now, you have to know what it is. You have to know the relationship between pressure and surface area, and we have to be able to convert with 5 different units. Okay? And once you can do that, we're ready to talk about the gas laws. All right, so how are pressure and surface area related?
They are not.
They're not.
The definition.
Can you repeat the question?
It's on the board.
Oh.
How are pressure and surface area related? Write it down and I'll let you figure it out for yourself. I'll make you stand up.
Figure it out.
Yes, you can.
Okay.
Less space.
The more surface area, the more pressure it is.
All right, write it down and I'll have you figure it out. It's easy to figure out.
Because you have pressure under here, up here, Paul. Under pressure.
Let's see if I have any ISS folks today.
Yeah.
Oh, yeah. If we're like super seven,
She
we're more
she's
spread out,
cussing
and there's
her
less
for
pressure.
this
So
is
if
in her,
we're more together,
give
then
her
you get it.
ISS. I think that's right, and that's on.
Where? As long as I
Every day. Precious, she's right next to me.
So.
I feel like they just wanted to put somebody
No.
in ISS.
She was
That's
having
what-
Right. She was like, this isn't, what is your beat?
Yeah.
I was like, okay.
Okay. All right, so stand up beside your desk or in front of your desk or somewhere. Somewhere where you can stand.
Guess I got
under pressure.
There's like 8 million leaves beside the door. Don't try to go out.
What are we doing?
Oh, stand up. You're going to figure out the difference or how pressure and surface area are related.
You make it.
All right, so what is our surface area right now?
What?
What's our surface area? What are y'all doing?
Standing.
So what's our surface area?
Up.
With the ground?
So what's touching the ground?
My feet.
Our feet. Okay, so the bottom of our shoes are our surface area. Okay, what creates our pressure?
Our weight.
Our weight. Okay, our body weight creates our pressure. Our surface area is the bottom of our shoes touching the floor. Okay, so stand on your toes. Oh, it messes up your shoes. Okay, well, for the rest of us, pretend you do it. You walked in heels at some point in your life, right? Okay. Have you, Miss, I don't want to bend up my shoes?
Yes, I have.
Okay, you have. So, what happens when you stand on your toes? What happens to your surface area?
It gets
It
smaller.
gets smaller. What happens to the pressure on your front of your feet?
It gets heavier.
It gets a lot more. So, what's the relationship between surface area and pressure?
The less surface area, the
Less
more
surface area.
pressure.
More pressure. Okay? So, what is the relationship? What's the word we want to use?
Inversely proportional.
So, y'all will have learned something this semester.
I learned a lot in this class only. Right.
All right, so they're inversely proportional.
I could.
As surface area increases, pressure decreases, or you can write it the other way. As surface area decreases, pressure increases. It doesn't matter to me. They're inversely proportional. As one increases, the other decreases.
This class has been.
All right, we got it? Yes, no? All right, so pressure has 5 different units y'all have to know and be able to use. Okay? So the 5 units you have to be able to use are those. All right, ATM does not stand for the bank machine. ATM stands for atmospheres.
Yes.
Wait, what?
These are the 5 pressure units you're gonna use. mmHg stands for millimeters of mercury. Sometimes they might just write mm, but most of the time you'll see mmHg. Okay, but if you ever see just mm, it is millimeters of mercury. All right, torr is Torricelli, and it's named after the guy who created the barometer, because we use a barometer to measure pressure. So what?
Is he Italian?
He is Italian. Pascal did a lot with the gas laws of pressure, and so they named it after him, but his is really big. It's got an exponent. So we also use kilopascals.
I don't know what they were doing in Italy, but like they were on something because they came up with a lot of stuff.
Cool.
What does America do?
We were a little.
Kill people.
Remember, a lot of this stuff was done when America wasn't really high functioning at that point in time. We were still colonies when a lot of this stuff
Right, we
was done.
just take credit for everything everybody else did.
Mr. Columbus.
I was reading yesterday, we really just pushed these territories by the whole We're just not the best people. But that's
Really are. I'm not killer. They not. We're not from here.
right. We're not from. Oh, we from the Dominican Republic too. You didn't know that before?
Okay.
It just came from the Dominican Republic.
Okay.
Pascal.
All right. So, along with all of these units, you have to know what each of them stands for. So, there are the numbers that go with each of them. Okay, now Zyra's really making a face at me. I don't know if she was just yawning or if she's like, okay, or if she's like, this wall is nuts.
Let her make faces.
I want some oodles and noodles.
Freedom, what?
Oh, I felt that.
Right. Like, she could just be looking at the sky sad or something. Miss Wall, you're so sad about
My teeth are gonna get
chemistry.
really bad. She's like, why are you making faces at me?
I think Miss Wall really want to say about chemistry.
Right.
You
We
sad about
don't hate
chemistry?
this class.
Right.
Not really. I was sad yesterday that I had to go to a staff meeting, but, you know.
Just say,
It is
forget
what it
y'all.
is.
Y'all are nothing without me. That's what you tell me.
You do the same stuff at every staff meeting since you've been here for so long?
No, we're doing a book study right now.
Like that same book that she was reading last time when she read the day it was due.
We've only done chapters 1 through 3. I usually read it the day at the staff meeting because it's so scintillating. I'll forget what it said.
That
I
was
like
you
that
reading
too.
during your test?
Huh?
That was you was reading during your test?
Yeah.
yesterday?
Miss Wall,
You didn't believe you're smarter than your
coworkers?
You are.
No.
Are you smart enough, fifth grade?
That's not the
She's not
mindset she
smart.
had. You literally are.
She's only saying that because we're
No.
online.
Right.
Oh, I forgot.
All they are boot compared to Miss Wall. Not all of you, but most of you.
No, it's pretty much all of you.
Right.
Now, some of them I like, but I'll never tell you who those people are.
Really?
Can
Well,
we
what
just-
if we graduated? What if it's like the last day of school?
Do you like Joe?
Oh, yeah.
Nope.
So how about you say on your last day? What they gonna say?
You should have just like.
Nope.
I thought it was a person.
Miss Heflin.
I wouldn't be included.
Never tell you.
You know, I don't tell her.
Yeah, it was
No decent person like Miss Hefler.
Yeah.
I don't really know Miss Hepworth.
You don't want to get it.
I just take y'all's word for it. I don't know her that well.
As a teacher, when I would go to her class to get the keys from my brother to go to attendance, and she'd be like, no, you can come to class though.
As if you was already in the classroom, like she does things with
Am I expecting? Yes.
All right, everybody got the numbers? All right. So let's say that we have 652 millimeters of mercury, and we want to go to KPA. Okay? Now, there's 2 different ways you could convert this, and you can choose the way that you like best. Okay? So,
Is this an example?
now, some of you would look at this and you would be like, okay, I can go millimeters of mercury. Millimeters of mercury is equal to a what? To 1 ATM. So you would say, I could go to ATM or atmospheres, And then I could go atmospheres to kilopascals. And that's one way that you could do it.
Yeah.
Okay? It's not how I do it.
Is your way easier?
Shorter.
Oh.
Now, the nice thing about pressure conversions is they're very much like moles, except that, you know how moles could have coefficients in them that are not ones? We're coming back to that in a little bit, by the way, next week. So here, you don't have to put in the 1 ATM because when you look at this, what do you notice about all of this right here? They're all 1 ATMs. So these are all equal to one another. So do you have to put one atmosphere into the chart? No, these four things are all equal to each other. So you can just say millimeters of mercury to not atmospheres, dummy.
Okay.
Going to KPA. All right, so you could just go millimeters of mercury to KPA. So when you look at the chart, what is a KPA equal to?
KPA.
101.325.
That is too long.
Yes.
No.
You will know most of them by the time you use them in the word problems. Millimeters of mercury is equal to what? 760. Notice about torr millimeters of mercury, though. They're what? They're the same. So that makes it easier.
Wait, is that other number the same as just the decimal number?
Yes. And you could also, if you wanted to, you could learn KPA, and then you could just change it by doing your 1,000 and converting, which would cut down on what you have to memorize. All right. Now, calculate, and you have your answer.
Okay.
Sorry?
I need a second to process everything you just did.
Now, if you find your orange tables, you don't have to do it at this moment, but at the very top of the orange tables on the front page in the first table, 3 of those numbers are given. Okay? You might want to note that this one here is not on the reference table. So to help Precious out, since she said, I got to memorize those, technically the answer is no. The top 3 are on your reference table. The one I just wrote that I wrote not on the reference table is not on the reference table. However, will I use PA?
No. Yes.
You will see PA on my test and on my quiz. Okay? You're in an honors class. I'm not going to eliminate PA just because the state didn't put it on the reference table. Okay? You got it? Fabulous. All right. So did anybody calculate as an answer for this? Or do I need to get my calculator and do it? Is what? 86.92. And then put KPA. All right, questions? I will tell you now that as long as your significant digits are within 1, I will not take off of this unit for significant digits.
But if we were this, it would be.
It'd be 86.9. Okay?
Oh, I saw you made it fucked up the other day. When I'm at school, it's like. I know.
Ooh. All right. So we're going to divide up our gas laws into 2 sections. Oh. We're going to divide them up. Yeah, we're doing if time. I got time today. It's like rare it happens, but we're here today. All right. So.
How do you have time if we
I know.
That's just a problem.
It just happens on some days.
So this is a new thing.
Here.
Boil low. Boil.
Whoa, my baby.
Boil?
Yeah.
Okay.
There. Doesn't say if time anymore. Now, I divide the gas laws up into 2 sections. The ones that have no mass in moles and the ones that do have mass in moles. So for the next 2 days, we're going to work math problems that have no grams, no moles. Okay? So we're going to focus on the ones that have pressure, volume, and temperature. Okay? So there'll be no moles in these questions. Now, Boyle's law is going to investigate pressure and volume at constant temperature. Okay? Now, when I write P and V, I'm talking about what?
Pressure,
And constant T would be
temperature.
good, because I'm going to abbreviate that all the way through here. Now, you guys are expected to understand the basic tenets of how the gas laws work, okay? Because on the exam, they may not ask you to calculate. They might ask you something about the gas law itself. So, let's say that I have a 1 liter container. I put an ugly thermometer in it. It looks like a giant pickle.
Pickles are good. No, they're not.
Yes, they are.
Yeah,
Pickles are disgusting.
I mean,
no, the pickle spears, that's where it's at. The pickles, period.
No.
Yeah, crazy.
vinegar?
Yes.
Yeah.
What are you talking about? I like it.
I get the-
No, some people do drink it like to lose.
That's thermometer.
Oh, that's
Yeah.
okay.
No thermometer got a butt at the end.
Yeah. I don't think I
Stop making fun of the thermometer. I was asking a very important question to my thermometer.
All right, so I made the temperature 25, so it's constant, right? Now, the number of dots are equal because moles are not changing. They're not part of our discussion. Okay, so even though I did not count the number of dots, all right, the moles are not part of our discussion. So just draw in some dots and write that the number of dots are not changing. All right, you do not have to count to make sure that they're the same.
I'm confused. The liters?
What did I do to the liters on the container?
I don't know.
One is 1 liter, and what I do to the
I
other?
took a half.
I cut it in half. I cut it.
So wait, is the whole thing a liter? Like, is it liters? Is that what the boxes are?
Yeah, the boxes are the liters.
Oh.
So I decreased my volume by half. Okay? So we have to figure out how pressure responds to that. Okay? That's the goal of this, is to talk about what happens to pressure.
Gets more pressure
That's what we got to talk about, is why.
because the surface area is smaller.
All right. So in order to talk about what happens to pressure when I change the volume, the thing we have to know before we do this, because we're going to do it with all the gas laws we're going to talk about, is what creates the pressure inside of the container? Some of you probably know and some of you don't.
Temperature.
Okay? And I can't just have an answer of temperature. What physically creates the pressure inside the container? Zyra, what can't your readers see?
Moving molecules.
Oh, yeah. What creates the pressure? Let me back it up a little bit. What creates the pressure inside the container? Does that help?
Friction.
Okay. Not friction.
Moving particles.
All right, what do the moving particles do?
Vibrating.
And
Move.
Moving.
what do they do when they move?
Heat up.
Hold on.
Temperature's constant. What?
Expand.
Nope.
I don't know that.
Rotate.
And
Translate.
Vibrate.
all right, the particles are vibrating, rotating, and translating. They're doing all of those 3 things. It's covered. What else do they do?
They, you know,
Get closer. Farther apart.
that's what
Bigger. Littler.
What do they have to do in relationship to each other?
They hit each other in the basket.
They what now?
Hit each other in the basket.
All right, so the
What?
particles,
Hit each other and pass kinetic energy.
Okay.
all right, they hit each other, and what else?
Elastic.
I don't care about that part. All right, they hit each other, and what else?
Move. One stops, the other. I don't know.
And the container walls. Now, the pressure comes from hitting the other particles and hitting the container walls. Okay? That's what creates the pressure.
Is
So-
that like when you open soda?
Yes.
And it's like,
Yeah, that sound is called actually effervescence.
I mean,
Okay.
I was talking about the sound. I was talking about how the bottle gets.
Yes. Yes.
Okay.
Okay.
Well, it really did.
Now, particles hit each other and the container walls. All right, so pressure comes from these little particles in here hitting the walls. Whoops, I'm erasing the walls. All right, and each other. So if I decrease, change colors. If I decrease the volume, okay, what are the particles going to do? Will they hit each other more often or less often if they have less space to move around? All right, let's say that we take this room and I put all of you in this square between Victor, me, and the bookcase, and I make you move around. Are you going to hit each other more often or less often? You're going to hit each other more often. Okay, there's less space to move around. Let's say I send y'all to the main office right now. Send y'all up the hallway. It is 9:32. Are there many people in the hallway? I would dare say every one of you can get up the main hall to the office and not bump into a soul. Now, what if I make you go at the bell at 9:40? Probably going to bump into a lot of people, okay? Because the halls have a bunch of people in it, right? So, if we decrease the volume, there is less space. There will be more collisions. So pressure will increase. Does that make sense? Anytime there's less space, there will be more collisions. Where there's more collisions, pressure goes up. You with me on that? Allie, since you said you didn't understand that a minute ago, are you with me on that?
Yeah.
Okay.
Who said they didn't
I
understand?
thought you did a second ago. Maybe it was somebody else who said that.
I mean, I probably could have said it, but I don't remember what you said.
So, what's the relationship then?
Inversely proportional.
So, pressure and volume are inversely proportional at constant temperature, and I'm going to write and moles in brackets. Okay? So pressure and volume are inversely proportional at constant temperature and moles. So when one goes up, the other goes down, and temperature has to stay constant. Okay? Are you with me on that?
Yes.
Okay. Now, the last thing we need is the formula. So let everybody catch up and I'll write the formula down.
Spaghetti.
Are we there? Okay. So the formula for this one is P1 V1 equals P2 V2. Now, what do you notice is not in the formula? Temperature. Why is temperature not in the formula? Because temperature is constant. Does that make sense to everybody? Make sure I'm right on the time. Where are we at? Yeah, I am.
Cause you gotta live.
Here, I'm gonna make Xavier be my able-bodied assistant. The one that Xavier is giving you is homework for tonight. It says gas law conversions on it, 1 through 10. Now, the one that I'm giving you is for the people who are not gonna be here tomorrow. So those who are not gonna be here tomorrow, put your hands in the air. So you have your homework sheet. Because you're gonna need to check the website. Well,
I'm not gonna be here, but I'm not going upstairs.
Who else on this side's not here tomorrow?
Franco, you don't gotta know.
Nobody else on this side?
side?
I got everybody who's not here tomorrow.
You're moving so slow.
All right.
Because my hands are ashy. I can't move
My
the
hands are
table.
ashy.
Do you need me to take over Ashy Man?
No, I'm about to.
Ashy man. But does anybody have lotion?
Ashy.
Can't grip the paper like I want to.
Oh my God.
You know, if y'all got